Right, so these are YouTube style videos of your problem sheets with MATLAB. I thought it'd be useful to actually show you how you actually implement it in MATLAB rather than just giving you the scripts. So first of all, before doing the first exercise, I'm actually going to talk about MATLAB in general. So I'm using a Mac, but your screen should look pretty much the same. So here on the right hand side, this big window is what we call the command window, where you'll actually type in, you can see where the cursor is now, the commands that you want to do. The top left is a directory, so I'm currently in my documents, MATLAB documents and problem class 1, and we see that we already have a file in there. And the bottom left hand corner is something we call the workspace. The workspace is where we record any variables that we type in, and we'll see them come up as we type the variables in for the first exercise. Right, to do the first exercise, it's quite a simple exercise, so I just want you to define some variables. A equals 2, B equals pi, V is a row vector 1, 1, 2, and A is a 3 by 3 matrix. So let's do that to start with. So A equals 2, B equals pi. So pi is actually a built-in variable in MATLAB. So for example, I can't set pi equals to 2. And the next one is V is a row vector 1, 1, 2, and A is going to be a matrix which is 1, 0, 1. Semicolon means new line, 0, 0, 1, 3, and the final row 0, 0, 2. Okay, that's great. So next I want you to compute, if possible, the following quantities. So the first quantity is just A times B, so that's going to be 2 times pi. The next quantity is B times vector V, so that basically multiplies 2 by every element of V, and pi by every element of V. And the next one is V transpose times V, so we can write transpose V times V, so that's the right answer, which gives us a vector as expected. There's also shorthand for this, for transpose is using prime, so V prime times V gives us the same answer we see. Right, now we want to do a matrix times a vector, so matrix A times by V. We see we get an error here as expected because A is a 3 by 3 and V is a 1 by 3, so the inner dimensions of the matrix and vector don't agree. But we should be able to do the next one, which is A times V transpose. So that's a 3 by 3 times a 3 by 1, so the inner dimensions agree. And then we want to do matrix A times A transpose, which gives us a matrix. And then finally we want to find the inverse of A times the transpose of V. So inv A times V transpose. Right, and then the final part of this question is we want to see how we update variables. So we want to set the second element of V to 10 and the 1, 3 element of A to 5. So that's V2 equals 10. You can see the second element of V is now changed to 10, and then A13 to 5. That's it for question 1.